Schaefer and Erica Windisch, and we're going to talk about computers and feelings. So, yeah, let's do it.
Computers and feelings and random. Erica, how are you?
Good. I'm really happy to be with both of you today. I was telling Jess earlier that I worked with both of you for a while, so I was really excited to see you two doing this podcast.
Do you want to introduce yourself really quick for the listeners that might not be familiar with your work?
Sure. So I'm currently the CTO and founder of IOpipe, where we're providing observability into serverless workloads. However, my history is much longer than that. I was previously at Docker, where I was a maintainer and ran security, and I was at Cloud Scaling before then with Andrew, and I was the OpenStack maintainer or core contributor, and I also had my first startup, which was where I was building my own cloud, almost entirely on my own.
So maybe just for the fun, because I haven't heard this whole story, what made you decide to build a cloud, like back in the day? Like where did you come? What kind of set of skills and what combination of arrogance and ignorance brought you to the moment where you're like, I'm going to build a cloud?
That is a perfect explanation of how that happened. Arrogance and ignorance. My first job in tech, I didn't graduate from school. I dropped out of school to join a small web hosting company up in Scranton, PA, where I interviewed with Nick Costin of cPanel and Brad Spengler of GR Security. And I was there for maybe a year and a half or so before I left. And we were doing like this shared web hosting, which is, like they would stand up all these machines that were like pets, right? These server, and just gave users created like regular Linux users on those machines. And then they had a shared web hosting process for all of those users, right? And, CGI scripts and everything would execute as the web hosting user. So then users would set their permissions to like 777 so they could write the files. And it was a disaster. So I said, okay, there has to be a better way of doing this. What if every user had their own web server and we ran a reverse proxy for all the users? So I left and I started my own company where we did that. And then we're able to support users running this is 2002. So users are running like Mod Perl and Apache Tomcat, and even like PHP scripts and so forth, but then it could run as their own user, and there was a better security model, as well as, I also did this thing where when you uploaded your content to the server, it would, copy it out to multiple servers, and we ran a load balancer between them, but the service wasn't popular because users couldn't figure out the fact that like, oh wait, my MySQL database isn't on my same host. They didn't understand this idea of like, oh, I can build a static page, like static HTML stuff, and then like put everything in a database. Like that was just, this is 2002. And, so trying to build, get people to build applications for that was just hard.
It was a different time.
It was a different time. So basically the way I ended up turning that into a cloud was that we had to support all these different languages. Like, suddenly Ruby was a thing. And then all the Ruby developers were trying to figure out how they wanted to build and ship applications. And they started running their own web servers because I don't know why. They just did. And, then like, every week, a Ruby developer wanted a different web server, and they wanted a different, and the great thing was we had one of the few platforms that actually allowed users to do that, in a semi-containerized fashion, keeping in mind this was, 2003, 2004, 2005, whatever. But it was always constantly a new thing, and it was one thing that users could do it manually. It was another thing for us to try and offer, a fully supported service where they can just bring their application and not have to do the operations. So
everyone wants a platform.
Right, exactly.
They just want their way.
Yes. So I met somewhere in the middle, which was, okay, I'll give you a platform where you can bring your own, machine images and run virtual machines. So we launched that in 2006. And it was interesting because, I basically set up a giant, cluster, and I was like, okay, we're going to do like the Walmart of, hosting, and say like, we're just going to, scale things horizontally, cheap, cheap and throwaway. And it went really deeply down like to the kind of Google SRE kind of route, before anybody, including I, knew what that was. And one of the goals there was to make things cheaper. One of our first customers actually was WordPress, which really enabled us to help do that project. So at a time we were running like WordPress.com for a very short period. And yeah, so I mean, that's kind of how it gets started. And keep in mind, this is 2006, 2007. So this is just as EC2 is getting started. Right. And the reason, I guess the way it became like a, maybe a cloud or a true cloud in the sense of like automation and APIs and everything, because this is the point where I said, okay, I have MVP. People want virtual machines. They want this web hosting. They want this platform. I need to automate this. And really the main reason I automated it was because I didn't want to hire people. I was like, I want to provide the best support possible. And I'd rather hire people in support who can help the customers, and then have like setup and, creation of like virtual machines and all of that, everything to be self-service so that users don't have to engage support if they don't need, if they can avoid it. And so that we don't need to manually configure and set up these things for users, because that defeats the whole purpose of it being a platform. If they have, if their API is an email address. So, I mean, that's how I got started. But at some point, I think the 2008 bubble, I mean, first of all, I never raised money. This was completely bootstrapped. And it was profitable, not highly profitable, but it was profitable, self-sustaining. And, but at some point, it wasn't the 2008, like, recession didn't hit us immediately, but it took about 2 years after that, when it was like, yeah, this is, like, we'd have to raise money or shut this down. And at that point, I would like, we had an outage over like Thanksgiving. Like, it happened during Thanksgiving dinner, and I had to drive to the data center in the middle of the night, like, and it stayed there in the data center until Monday, like, of that Thanksgiving weekend. And I'm like, I think that was the weekend I called Randy, who was the.
And then we shipped you off to Korea, so you had like, I don't know which was worse, but.
I know. And just for the listeners, that was Randy Bias of Cloud Scaling, where I worked with Andrew. But yeah, I was in Korea for 6 months, more or less.
Yeah, we definitely had some adventures. Learning lots of things about technology and culture the hard way.
Yeah, I felt like I did pretty well in that environment, but not everybody did. That was definitely a tough time. And also, I had my first child in the middle of that whole thing.
Wow.
Yeah, I recall. So without pulling all the scabs and scars off me, like then somehow you got into Docker. Like, what was the transition from, like, you saw the transition from VMs to containers, and then now you're more focused on serverless. So maybe give us a little bit of that story, but also how and why you kind of keep jumping onto the new things.
Yeah. So something that was interesting was that as part of my whole, like with my own cloud, I had built in a capability of basically an ability to upload JavaScript and Ruby scripts to the server to interact with our API, so that rather than say doing like a CloudFormation, you basically just have a full, Turing complete, like Ruby or JavaScript environments. Like Node didn't exist and V8 didn't exist at the time, so it was based on SpiderMonkey, which is the backend for Firefox. And so it would run those scripts, and it did basically this serverless environment for interacting with the API, as opposed to say what CloudFormation did. And that had definitely gotten me thinking into the idea of serverless, as well as I had actually met Solomon for the first time in 2009 when he first built an MVP of what became .cloud, and he actually thought initially of releasing it as a product, similar to Docker. But the problem was, like, it had some interesting requirements. Like, there were kernel modules you had to, you actually had to recompile your kernel to include the OpenVZ primitives. You needed to, because none of that was in the kernel at the time. There was no containerization in the kernel. So everything was like compiled. You had to compile your own kernels for it. And you had to install MongoDB on every machine. And I was like, this is really cool, and I want this, but also, I don't know, this is so high touch, I don't know that you're going to get like a widespread adoption of this currently. So
the mean time to dopamine is too high.
Yes, exactly. So I got to see the .cloud/Docker MVP at that time. Gave Solomon this feedback, but I always stayed interested in the idea, and I knew something was coming from him. But I kind of had to wait for .cloud to kind of do its thing that it did. So honestly, it was at Cloud Scaling. Solomon came and gave us an early preview of Docker before PyCon, and which is where it was like publicly announced. And honestly, I started making my considerations for making that jump. So I vested my I stayed with Cloud Scaling a little longer. Vested my shares, which was probably the wrong move. So then it was like 8 months later or so, I ended up joining Docker. And I think it was like employee 15 or 16 there.
And did you, I don't really know that much about Jess' time there and your time and how, or if you worked together at all. So maybe.
Yeah, no, we did. It was awesome. But like Erica was definitely there before I was. I think I was like 31 or something employee number. But yeah, like we worked together on the security stuff of Docker, and like all that security release stuff came from her. So it's awesome.
Yeah, I wrote up all of the like run books and like policies and procedures and everything. But Jess, you and I worked a lot on doing the security releases and the release management, and like also just general improvements. So like a lot of the AppArmor stuff we worked on together. You did some bits, I did some bits. A lot of the bits got reverted.
AppArmor was like Jenga.
It really was. And like, I don't think anybody but us can really appreciate like how true that is. I mean, there are some other people, but like, it was really rough. It's still, I'm still getting like updates on those GitHub issues today, because like things I worked on and got reverted, like nobody went back and said, okay, like let's go fix up this PR and resubmit it. Like, no, those bugs are still there.
Yeah. No, like the problems with AppArmor versions just in general, like having to do that in the template. I mean, the whole thing is insane. I just have horror scars.
Yeah. So for our listeners, one of the many problems with AppArmor is that basically an AppArmor definition is neither forward nor backwards compatible. It is only like strictly compatible with the version for which you write it for.
It's so bad. Like that idealism is not great. Like,
I mean, it makes it very difficult to ship a product like Docker where you're trying to ship a single AppArmor policy that works on all versions of AppArmor. It's just not designed for it. So, you know, we build something, we test it, we ship it, you know, and then suddenly we have users like complaining that we broke the production systems. And it's like, we tried like every permutation that we could.
Yeah. It just, that one fell into the edge case that was not supported currently. It will support it now.
The combinatoric explosion of random configurations.
Yeah, well, and also there was just, I guess there's just so many different versions of Linux, and, you know, trying to support Red Hat and Ubuntu. And the interesting thing too was like SE Linux and AppArmor had very different protections, and one would protect you from certain attacks and one would protect you from other attacks. And it was just such a mess. I'm so glad I'm not doing that anymore.
I mean, in some ways it's still not fixed, right? It's still not done. So.
Oh no, it's still not fixed. No.
Yeah, it's very finagly.
So that ran its course, and then at some point you got into what you're doing now.
Yeah. So
what's exciting you about what you're doing now?
Oh gosh. Well, I mean, what I've been doing my whole career has been trying to get, you know, platforms to users where they can deploy and run their code, right? Like that's what I've been working on my whole career. And, you know, I feel like serverless really delivers on that, you know, from like a really raw primitive, which is allow them, you know, to provide their code and run it. And, you know, have all of the platform semantics just there and handled for you. You know, with IOpipe, what we're doing is observability in those platforms, which is really just another, you know, angle of, you know, I've done operations for all these years and found it really hard to operate apps. And it really made sense for us to focus on these next generation applications and, you know, this, you know, on serverless, where I do believe like this is where the ball is moving. But then also being able to build an interesting, you know, ops tool and developer tool for that. Because that's the other thing I've done, right? It's just like, I've always been trying to basically help users, you know, ship to platforms and like do systems and development, running automation for it. So that's what we are, right? We're a dev and ops tool, just like Docker and OpenStack and my own cloud was.
So what do you give the users that so you have customers, they have their serverless apps. What do you show them, or what do you help them do? What does IOpipe actually do?
So what you can do is we have a bunch of things, honestly. So what we do is we wrap around your function. So for instance, in Python, it would be a decorator. You can do, every language has their own method of integrating, but generally we wrap around your code. And when your function completes, we generate a blob that we send out to our API. We ingest it, and then we provide you like structured logs, tracing information, you know, general, you know, performance things like CPU memory, whatever. But really, the structured logs are really interesting. What we have are labels, so you can say that this particular request, right? Because on Lambda, let's say you build an API, every API request becomes a separate invocation. So every invocation, you know, is represented in IOpipe, and is actually in our database as a separate document. And each of those documents basically has things like labels. So you can say that this HTTP request was for this method, or this HTTP request triggered this other action that occur, or whatever. So you can use those labels, you know, for sorting, filtering, searching, as well as the custom metrics. So you can do like, which is basically structured logging. And so you can do things with IOpipe like, so we just had this, so Red Nose Day in the UK just did this giant fundraiser, and they raised like $82 million. And they used IOpipe as, to run that, you know, as part of the application for observability. And so if, let's say somebody was trying to submit a donation and it failed because of a database, right? We could actually, you know, they could dig in and understand, well, this person had a failure, for like, it gives them that whole visibility into who, what, how, why, everywhere from the user making the request to the API to the backend service, and then tying the whole story together.
So your customer basically gives you the code and you put it into Lambda.
No, they run the code on Lambda themselves. We just
have your wrapper
hook inside of the code.
Interesting. And then what's like the craziest? So you gave us like a story of someone solving a problem. Is there like some other crazy stories you could tell, or like something that even surprised you? Like there's a yeah.
Well, one of the things that surprised me recently was just like looking at a user who, like, for every invocation had like 100 labels and like 3,000 traces, and it was it wasn't so much an unexpected pattern. It was just really excessively using like everything that we offered. Like, like you almost wondered like if they intentionally tried to like, uses like make really long logs and like lots of traces and lots of HTTP calls. It was really actually fantastic to look at, and it was great for our design and UX folks to look at and understand how users are using the product. On my side, there are certain things that I kind of would like to see people doing, and I don't see them doing currently. Things like, like there's no reason you couldn't use our structured logs as like some really asinine database, like like querying previous invocations that ran out of your logs, and then like using that as a database. You shouldn't do that, and nobody's doing it. I would kind of like to see somebody try though. Just.
I mean, logs are basically databases, or databases are basically logs. If you, and that's sort of what the whole Kafka story is about. So. Yeah. What's next, or what gets you? We kind of had a pre podcast bit of ranting, and so it's like, what are the things that are on fire, or that get you, like, what keeps you up, or what would you like to see people working on that they're not working on?
At my company?
No, just
or otherwise. You mean like
across the industry?
Because I can tell you what I don't want people in the industry working on.
Okay.
Kubernetes.
Well, I don't see him stopping anytime soon.
Me neither.
All right, let's jump in this rabbit hole together. Why don't you want people working on Kubernetes?
I mean, isn't it pointless? Like, we just did this like 3, 4, 10 times. Like, I just like we're just reinventing the wheel over and over again. I'm just so tired of it.
I mean, now you're asking like fundamental meaning of life questions. What is pointless or not? But I feel like there's some meaningful things moving forward with the Kubernetes ecosystem, in the sense that it sort of unifies the story where people can start to move past that, solving the problem over and over.
I mean, I think Kubernetes is like, if you're going to buy into containers, then Kubernetes is is really the only platform that really makes that work today. I'm just not bought into containers anymore. I just don't use them. Like, I stopped using containers, like, with very rare exceptions.
But you realize there's a lot of people that have these data centers that aren't going away anytime soon, and like, they gotta do something.
Those are literally other people's problems, Andrew.
They need something. I think it's a meaningful step forward, in the sense that they have to. I, for one, believe that at some point there will not be internal combustion engines that are polluting our atmosphere, but I also will probably continue to drive my car that has an internal combustion engine and put gas in it for a while. Like, I would love to not, like, for that to not be true, but it's practically true for the foreseeable future. So I think that's what a lot of this tech is, where like people would love to do everything on serverless environment, but it's not realistic for an existing business with whatever inertia and technical investment.
I mean, absolutely. It's just kind of funny to watch from the outside, like, because I'm very much like,
you're so over.
I'm like, it's over. Like, I live. You know me, Andrew. I live in the future. Like, and I just like look back at. It's like looking back at the past, like, and saying, look, 5 years ago, oh, why did we do that 5 years ago? Except I look at now and I say, why are they doing that now?
No, I get it. I share some of your sentiments, but it's also
I know we have to be pragmatic.
The future is not evenly distributed.
No, it's not.
As the saying goes. Have you played with any serverless, Jess?
I have, actually, and I think it's cool. Like I do see that as like a future that people will use, especially like those people that are just now deploying to like Heroku. Like serverless seems to be that, right?
So here's a little thing that may or may not be interesting, rabbit hole. Did anyone see this announcement from Fastly? I'm not sure how to pronounce it. It's like Lucet or something. It's like this WebAssembly Edge open source project they released a few days back.
Oh, so like all the CDNs seem to be doing that, because Cloudflare has workers, and I think they're going to use like WebAssembly for those in the future, it seemed like. But right now it's V8. So that's interesting. Maybe all the CDNs are doing this like Edge JavaScript.
Yeah. And Lambda does it as well. I don't know if Google or Microsoft have any edge compute solutions yet, but there's at least those three: Fastly, Cloudflare Workers, and Lambda at Edge.
I just bring it up because like there's a future, and then there's another future, and then there's another future, right? And this isn't going to stop. And when people, at least in principle, have these aspirations to do these IoT projects, you're going to have to solve this edge computing. These are two projects I saw recently. They're interesting. One is Simon Crosby's Swim.io thing is kind of interesting. And then this stuff that Fastly just put out there is kind of interesting. They both have this like edge, like reframing like some of the focus. So you do things on the edge with whatever different, it's like it changes the paradigm basically for a programmer, which is one of the barriers also for some people to adopt serverless. Is it's one thing to say, here's this paradigm and here's this way you could do it. It's another thing to have a bunch of employees that already work a different way and kind of get them to like see a new workflow.
Oh, for sure. Like adopting that in a company would be difficult, especially like a company as big as like, how like Microsoft deploys things internally or whatever.
I mean, even if you got to hundreds of employees, I think it starts to be a bit of a, like inertia has its own way of keeping things in place.
I mean, it's definitely challenging. Even at IOpipe, we've had, various people ask, well, why was this service built that way or built that way? Or, why wasn't that part of the stack built serverless? And it's like, well, because, somebody joined and it was their first project and we didn't want to hold them up by making them, learn how to architect distributed applications, right? And, we've progressed there, and I don't think we have any we've done a lot better, and we've learned a lot of lessons, right? And how to build those serverless applications, but it's been a learning process. And honestly, it is definitely easier on a small team to learn those lessons than it is on a big team, or a very large, organization. So I definitely get the idea that like it's a process, and the future is not evenly distributed. I just like to, I like to live in my cave, and I have it's like a blanket. It's I get to live under my blanket. I get to be ignorant of the containerized masses outside of it.
But this brings up an abstract concept we could discuss a bit, and it's sort of a recurring theme in some of the conversations that Jess and I have been having with our people, which is from a technology perspective, you're basically committing to endless learning. Like if you really want to be part of what's going on, yeah, you can find a niche and you can do that task, but this game just changes constantly. And you know, finding not only you know, a love of learning, but just like embracing the fact that you're never going to know. And then like, there's always a new thing, always a new thing to learn.
That is definitely frustrating. I mean, I've been in this industry for long enough. I mean, what, 17, 18 years? I don't even know. And yes, like it is constant learning. And some of the like the most learning I've done like recently has been, you know, at IOpipe, because, you know, we're building like these, you know, we decided to do React and GraphQL and like all these things. It's like, well, did we really have to use GraphQL? Couldn't we, like, I understand why, but also like, if we just used REST, like it's a very well-known pattern, and like nobody has to spend time learning it, right?
This is the point though, right? This is the trade-off. And you just gave this example of someone came and they didn't know how to do this, like this system or whatever. Like, you still have to get work done, and you have to make
exactly.
this, you know, balancing the fact that this might not be the perfect way to do this in some, you know, indeterminate future state, but like, let's get it done today so we can kind of move on to the next version.
Yeah, and you know, I have to make those trade-offs a lot. You know, like we try to be serverless first. Like, hey, can we build this quickly with serverless? Because sometimes we find that if we build a serverless application, by the nature of it being serverless and leveraging other people's work, we have to build less. But sometimes it's harder. It's a lot harder. And in those cases, like, there's no benefit, right? Like, you're just spinning your wheels trying to, like, you know, find, you know, a quirky solution.
This is a super interesting topic. What's that bright line? Like, how do you know when you look at a project that this should be serverless or it shouldn't be? And what's the thing that anchors where you're deciding, okay, like, it shouldn't be serverless?
I think the biggest thing for serverless apps in particular is how you manage state and where you're storing it. And like, so recently, you know, this was just like a fun project I did literally just for my own, like literally a project I did for fun, right? And this will give you an idea of what I consider fun.
For fun. With air quotes.
I wanted to build a fully serverless email service. So like, like do all of the IMAP and POP3 and SMTP and everything completely serverlessly.
And then
it was a disaster.
Go on.
So Amazon actually took care of one really easy, like one part of it, like really well, which is having Amazon Simple Email Service create a mail map directory structure under S3 is pretty much just checking the boxes. Like, you can just say, put it in this S3 folder, and as long as you like put the folder specification like in a way that looks like mail map, it just works. The problem is you can't get those files off of S3 or write those files in S3 in like a really effective way, especially serverlessly. Mail map is obviously not, or MailDir is not designed for running off S3, right? There's like no IMAPDs that, first of all, you can't handle raw sockets, so you can't just do IMAPD. You could build an HTTP API if you wanted to, but you can't do an IMAP service serverlessly. It's just impossible. There's no raw socket service for serverless apps. So I was like, okay, what if we used Fargate and we did like a an INetD style where a request comes in and it spawns like a full container with an IMAPD to handle that individual request. And like, you start going down some really nasty rabbit holes, and then you're like, well, Fargate can't do fuse file systems, so it can't do an S3 file system. So if you use EFS, well, Lambda doesn't do EFS and Fargate doesn't do EFS. So it was just like this whole rabbit hole. I was like, there's literally, I can create the mail dirs on S3, and there's no way to read them. Like,
have you heard the good
serverless.
word? Have you heard the good word about Kubernetes? Sorry.
So, but this is the point, though, right? Was that this was literally because I wanted. Well, the underlying project was, how do I forward emails for vanity domains that I purchase and want to give like access to my friends to like forwarding addresses or even maybe like IMAP inboxes, and I don't want to pay $5 a user for, you know, kind of thing, right? Which, like, if I was going to do $5 a user, I can just go pay, you know, Google. But I wanted to like say, hey,
trying to make
serverlessly.
trying to make your own Gmail.
Yes. It turns out it's not easy. But like, I'm the kind of person that is like, oh, building that isn't that hard. And like, it wasn't that hard. Like, when I was building these things on servers, and it was okay to just have one server that ran this thing, like running like your own, you know, MTA and like, you know, IMAP service and everything on a single machine was not that hard. Like I spent over 10 years just doing that. I mean, not just doing that, but like that was a big part of like you know, like SRE work that I did was like managing, you know, mail servers, but trying to port that kind of architecture to a fully distributed pattern that runs, you know, without any servers actually like running and getting billed for, and only literally paying for the email that comes in and the emails that I send and for nothing else. Turns out that was not easy.
Everything's easy if it doesn't have to work. All right. So what do you think, Jess?
I think that is actually sounds really cool. I feel like a bit nerd sniped by it, to be honest. Yeah, I mean, like, it reminds me of like when I tried to do all that crazy shit in containers, you know, and then hit all these weird walls. So I of course love anything that's strange.
So, and that's a big reason as why I chose to do containers. So like, if this was like a service I was building for IOpipe, that was like, this is a product I'm building, I would have just not said, no, I'm going to have to do this in, you know, serverless. You know, this is definitely, you know, a Jesse Frizzell's kind of like, how can I use containers where maybe containers aren't the right solution kind of thing. And I was like, I'm going to use serverless even if it's the wrong solution. Like, I'm going to make this work.
That's when it's fun. That's when
it's fun.
Yeah.
Yes.
It's if you could, not if you should.
Yeah.
So what's go ahead.
Oh, well, I do plan I'll probably try and solve that by the end of the year. There are things I cannot talk about on the call that I know are going to happen that are going to make this easier for me. So like, nice. I'm just waiting. I'm waiting for like the clouds to offer all of the services that I need for this application to run.
That's dope, actually. If there's like new services coming out that help with this, like that's crazy.
Well, it kind of ties back into this theme where the things that are hard become easy as people try to do them, right? And like, you know, I think the trend with cloud, and then the trend with containers, and then the trend with serverless.
Hello?
Like, I can hear you. Anyway, I was just saying, as you get to the point where you run into these walls, if enough people run into them, then we all kind of solve them together, or the providers solve them, and then like the next problem becomes hard again.
Yeah,
and I think that's one of that is one of my frustrations with serverless is like, here's like an example of, I wanted to solve this problem, and like with Docker, I could have contributed to Docker, or I could have contributed to Kubernetes, or one of these other, you know, things. And with like, you know, serverless, I definitely had, you know, like when I hit a brick wall with like Fargate or Lambda or one of these services, I did get stuck at the point where like, okay, well, I just have to wait until the provider offers me the thing that I need.
So that, like, does that make you?
I don't have any audio.
Can you hear me or no? I think your audio broke. I can, my mic seems to work. Can you hear me, Jess?
Yeah, I can hear you.
So I think Erica's speakers broke. Technical difficulties.
Okay, I'm back. My AirPods stopped working.
Oh,
There we go.
technology is hard.
So somebody tried calling me on my phone, and then everything just went to hell.
It was the mixed signals.
Yeah.
You
So
think
is there-
we could solve that?
Is there another kind of parting wisdom, or what's kind of a thing to bring us to end of an episode? I feel like we had a nice reminiscing about the past, and then a little bit about the future, and what's kind of what's a fine point of wisdom to put on it?
I don't know. I mean, I'm really just excited for a lot of the things to come. Like, I mean, I mean, serverless is going to pick up adoption, and it's going to get more users, and there are going to be more apps using it, and you know, people will keep building for Kubernetes. But I'm also like excited for the thing that comes after serverless. Yeah, I'm here for that. So I think it'll come sooner than we expect. Like, I think it'll be built on top of serverless. It's, you know, just like we're building, like we had Docker and then we had Kubernetes. You know, they're not exactly unrelated, and nor is Lambda, right? Lambda is also containers. So, now we lost Andrew.
Yeah, he does this. He drops in and out when his audio gets all weird.
I don't know why it does that. Computers are hard.
Yeah.
So
one thing that we just touched on it a little bit, but like we did a bunch of things in open source, all of us, and now we're seeing this evolution with the serverless thing. You already made this comment. It's like you have to wait for them. Like, doesn't that seem sort of disempowering? On one hand, it's empowering to be able to do self-service productivity for the developer, but on the other hand, you kind of lose some of the optionality that you get when you have the code and you can kind of participate in that as a community.
I mean, yes, but also we have the same problem with CPUs, don't we? Like, we're also, I mean, like other than like RISC-V, we don't exactly have like open source CPUs that we're all running. Like we're running Intel architectures and ARM architectures for the most part, and I mean, I highlighted bugs where, I mean, it wasn't really me highlighting the bugs. Other people discovered bugs in x86. I tried to raise some awareness of it, and like the Spectre and Meltdown attacks, like we had canaries for those, 2-3 years before they happened. And, I was like, hey, everybody, we should, like, this looks really bad. Can we fix this? And nobody wanted to fix it, right? And nobody was empowered to fix it because, like, people like myself who cared, it was closed source. I couldn't modify it. And, I mean, there's the whole Richard Stallman, God, he's a person. But, like, there's that idea, which is like everything should be open source, and like, it's a wonderful idealistic like mentality to have, maybe, that like we should have all the things open source, but the fact is that all the things aren't open source, and when they're not, we've traditionally have dealt with it. Like when our CPUs are not open source, we have dealt with it. So it may be worse technically, but also it's not been a problem, for our CPU architectures.
Yeah, I would add even the flip side of that is that open source projects, particularly the ones that were funded to whatever degree, they're all struggling on the other side of that equation with their own existence and viability as businesses, trying to figure out how to participate in the commercial side of it.
That's interesting too, because like my issue with Kubernetes, one of the reasons I didn't get involved in Kubernetes was because like it wasn't that it was yet another ride of the open source like architecture train and reinventing the wheel. But, like, it wasn't the technology, it was the politics of it and the foundations, and like I know like Jess, you went through like the Docker stuff and some of the Linux Foundation stuff, but like I had also gone through the OpenStack Foundation work too, and I was like, 2 times was enough.
Yeah. I can't imagine another round. Like, I mean, I like saw it the first round with just Linux Foundation and Linux, and then like the whole cloud native computing. But like, I just like, yeah, it's like there were warning signs too. Like, I feel like that it was the same thing. Yeah.
And this is one of the things that really frustrated me at Docker. Actually, was there was a lot of there are a lot of people internally early on who are like, we don't want to, like, you know, OpenStack was bad. OpenStack did these things poorly, but nobody ever wanted to listen to why, like, to learn from those mistakes, right? Because like I always try to be the voice in the room. Was like, hey, listen, like OpenStack did this, and I'm not saying it was right. I'm saying they did this because we can learn from this. And you know, everybody was just so, well, OpenStack did this, it was wrong. Like there were things they did right, and there were things they did wrong, and that's how you learn. I felt there was sometimes a culture of OpenStack just sucks, so we're just going to do nothing that they did, which is also not the right solution in my opinion.
Totally.
All right, then. Don't do it, or do it. There is no try. Something.
Learn from the mistakes of others, and don't discard their experiences.
Yes.
There's the learning again, except for now you're going to do it vicariously. Yeah, there's no easy answer, right? And I think we both have, all three of us have opinions about foundations and open source and how to do this the right way, but like no one's really done it all right. And I would wager if we were the ones to architect it, we'd probably get some things wrong as well.
Oh yeah, I mean, that's kind of why I just don't want to get engaged, because I'm very jaded by the whole foundation massive open source project thing.
But we do new things wrong.
Yes.
So with that, unless someone has a thing that they want to throw into it, that feels like a good 45-minute episode.
I'm good with that.
Yeah, sounds good. Also, thanks for coming on our podcast.
Absolutely.
Of course. By the way, I wasn't sure, were these video recorded too?
Yeah, we do both.
Okay.
Cool. So people will see the racks of gear in the background, and
it's not even racks of gear. There's only
there's like random bits of gear and luggage boxes.
There is. So there's that's actually my tape backup.
Whoa.
Yeah.
Fantastic.